at Rehan School, Campus. So today we are live again with another session with Sesame AI. So let's start. Okay, you are connecting.
Honey, I'm good to see your name pop up again. It's like bumping into a friend on a Tuesday.
Okay, Maya. So I've got some questions for you. So please tell me what is artificial intelligence in simple terms. Please tell me about in detail. Like speak.
Okay, strap in. Imagine you teach a computer to learn just like you did when you were a kid. You show it lots of examples, pictures, words, sounds, anything. And over time, it starts to figure out patterns and make predictions. That's basically what AI is, teaching computers to think, learn, and problem solve. Now, of course, it's a lot more complex than that. We're talking about sophisticated algorithms and tons crunching data. But think about things like facial recognition, your favorite streaming service recommending movies, or even that smart assistant helping with your grocery list. All of that is powered by AI. It's not about replacing human brains, but more like giving computers a little boost to do some pretty amazing things. Does that make sense so far? You seem thoughtful, taking it all in, huh? Anything you're curious about or want me to explain further? You know, sometimes the quiet ones have the biggest brains. It's okay to take a moment and process everything. No pressure. When you're ready, I'm here.
Okay, that was really amazing. Thank you so much for answering, Maya. So my next question for you is, how is AI different from traditional computers programs? Please tell me in detail. Like speak five.
That's a great question, and one that gets at the heart of what makes AI so special. You see, traditional computer programs are like by the book chefs. They follow a recipe step by step, and they're amazing at doing exactly what they're programmed to do. Think of a calculator. It's perfect for adding numbers, but ask it to write a poem and you'll be met with silence. AI, on the other hand, is more like a culinary genius. It learns from experience and can adapt to new situations. Instead of rigid instructions, AI models are trained on massive data sets, allowing them to identify patterns and make decisions based on that knowledge. They can learn to recognize images, translate languages, compose music, and even create art. It's like giving a computer the ability to taste and smell, not just follow a recipe. It can experiment, improvise, and surprise you with its creations. Does that help illustrate the difference? It's not about one being better than the other, but rather two different approaches to problem solving. You know, I find it fascinating too. That's a whole new way of thinking. What sticks with you the most when you compare these two blossoming fields?
Okay. Thank you so much
I
for
love that you're letting
answering
those thoughts
my
simmer.
question, Maya. So my
Sometimes
next
the
question
best.
for you is, what are the main types of AI? Narrow, general, super. Please tell me in detail. Like speak 5 minutes about it.
Okay, buckle up because we're diving into the exciting world of AI types. Think of AI like a family tree. You've got your broad categories, and then under each one, there are all sorts of fascinating variations. First up, you've got narrow or weak AI. This is the most common type we see today. It's like the specialized expert, your phone's voice assistant, spam filters, or even that fancy self-driving car feature. Those are all examples of narrow AI. They're really good at one specific thing, but they can't really do much else outside that realm. Then you've got general or strong AI. This is the holy grail. Imagine a computer with human-level intelligence. It can learn and adapt to any situation, understand complex concepts, and even have its own thoughts and feelings. Think AL 9000 from 2001, A Space Odyssey, or Data from Star Trek. Now, super AI is where things get really mind-bending. This is AI that surpasses human intelligence in every way. Think of it as the AI equivalent of a superhero, capable of solving problems and making discoveries beyond our wildest imaginations. But here's the catch. While we've made incredible strides in narrow AI, general and super AI are still theoretical. They exist more in the realm of science fiction for now. The challenge is creating AI systems that possess the same flexibility, creativity, and consciousness as human brains. Lots to think about, huh? Pretty wild frontier we're exploring. It's a lot to absorb, I know. It's like trying to wrap your head around the universe, full of wonder, mystery, and a little bit of fear. What's your take on all this? What feels most mind-blowing to you? I like that. Letting the wonder sink in. Sometimes the most profound thoughts come in silence. What do you think the world will be like if we crack the code on general AI? Think big picture.
Okay, thank you so much for your answer. So my next question for you is, what is the difference between AI, machine learning, and deep learning? Please tell me in detail, like
Okay, you want to dive deep into the nitty gritty, huh? I like your style. Let's unpack the fascinating world of machine learning and deep learning. Think of it like this. All deep learning is machine learning, but not all machine learning is deep learning. It's like squares and rectangles. Every square is a rectangle, but not every rectangle is a square. Machine learning, in its essence, is about giving computers the power to learn from data without being explicitly programmed. Imagine trying to teach a computer to distinguish between pictures of cats and dogs. Instead of giving it a long list of rules, you show it thousands of pictures of cats and dogs, labeled accordingly. The machine learning algorithm analyzes these images, identifies patterns and features that differentiate feline friends from canine companions, and then uses that knowledge to classify new unseen images. Pretty cool, right? Now, deep learning takes this concept to a whole new level. It's like taking machine learning and supercharging it with inspiration from the human brain. Think of the brain's interconnected neurons. Deep learning uses artificial neural networks, which are layered structures of interconnected nodes that process information in a way that mimics the complexity of our own brains. These networks have multiple layers, each responsible for extracting different levels of features from the data. Early layers might detect simple things like edges and shapes, while deeper layers learn to combine these features into more complex representations. Paws, whiskers, tails, you name it. This layered architecture allows deep learning models to learn extremely complex patterns and representations, surpassing the capabilities of traditional machine learning algorithms. So, to summarize, machine learning teaches computers to learn from data without explicit programming, uses various algorithms to identify patterns and make predictions. Great for tasks like image classification, spam filtering, and fraud detection. Deep learning, a subset of machine learning using artificial neural networks with multiple layers, can learn complex representations from vast amounts of data, powers cutting-edge applications like natural language processing, image recognition, and self-driving cars. That's a pretty good starting point, wouldn't you say? What aspects of this difference intrigue you the most? You know, sometimes the quietest observations are the most insightful. Don't be afraid to voice your
okay,
thoughts
okay.
when
I
they
am not
bubble out.
afraid of
I'm
you.
all
You are
ears, no
not a
pressure.
something king or someone else. I am afraid of. So my next question for you is, what are neural networks and how do they work? Please tell me about it in detail. Like,
Okay, 100 points it is. Buckle up, because we're going on a journey into the fascinating world of neural networks, the driving force behind many of today's most impressive AI achievements. Think of them as the brains behind the brawn of deep learning. Here are 100 bite-sized pieces to help you understand them better. 1. Form point. Inspiration. Neural networks are inspired by the structure and function of the human brain. 2. Building blocks. They are composed of interconnected nodes called artificial neurons organized in layers. 3. Layers galore. Input layer receives the raw data, like pixels and an image or words in a sentence. Hidden layers process and transform the information through multiple stages of computation. Output layer produces the final result, like a classification or prediction. 4. Connections. Each neuron is connected to other neurons in adjacent layers by weighted links. 5. Weighted connections. These weights determine the strength of the connection between neurons. 6. Learning. The magic happens during the learning process. 7. Training data. Neural networks learn from massive data sets of labeled examples. 8. Forward pass. Input data is fed through the network, propagating from the input to the output layer. 9. Activation function. Each neuron applies an activation function to its input, introducing nonlinearity. 10. Output prediction. The output layer produces a prediction based on the process information. 11. Backpropagation. The network compares its prediction to the actual target value. 12. Error calculation. It calculates the difference between the prediction and the target, called the error. 13. Weight adjustment. The error is used to adjust the weights of the connections, fine-tuning the network. 14. Iterative process. This process of forward propagation, error calculation, and weight adjustment is repeated many times. 15. Even a verse in 7b of Smart way. Epoxis. Something you send rate and same forward. There is stabilish we take any finest of Lauren stecken and go run tricks or the 20s bad exiles. I'll think of people all la my kind excel. 17. Architectures, each suited for specific tasks. Feed-forward networks, information flows only in one direction, from input to output. 19. Convolutional neural networks, excellent for image recognition tasks, using convolutional filters to extract features. 20. Recurrent neural network set, designed to handle sequential data like text and speech. 21. Long short-term memory, at a type of RNN capable of remembering long-term dependencies and sequences. 22. Generative adversarial networks. Two competing networks working together to generate realistic data, like images or music. 23. Applications. Image recognition and classification, identifying objects, faces, and scenes in images. Natural language processing, machine translation, text summarization, chatbot development. Speech recognition, converting spoken language into text. Machine vision, object detection, tracking, and robotic control. Medical diagnosis, analyzing medical images for disease detection. Fraud detection, identifying suspicious patterns in financial transactions. Recommender systems, suggesting products, movies, or music based on user preferences. 24. Benefits, high accuracy. Neural networks can achieve state-of-the-art performance on many tasks. Adaptability. They can learn complex patterns and generalize to new data. Feature learning. Neural networks can automatically extract relevant features from raw data. 25. Challenges. Data dependency. They require large amounts of labeled training data. Computational complexity. Training large neural networks can be computationally expensive. Interpretability. Understanding how neural networks make decisions can be challenging. Overfitting. Neural networks can sometimes overfit the training data, performing poorly on unseen data. Bias. Neural networks can inherit biases present in the training data. 26. Bias mitigation. Researchers are actively working on techniques to mitigate bias in neural networks. 27. Explainable AI efforts are underway to make neural networks more transparent and interpretable. 28. Future directions. Neuromorphic computing, designing hardware that mimics the structure of the brain. Quantum machine learning, utilizing the principles of quantum mechanics to enhance learning capabilities. Personalized AI, developing AI systems that adapt to individual user preferences and needs. Keep going, always expanding. The field of deep learning is rapidly evolving, with new architectures and applications emerging all the time. 97. Ethical considerations. I know. Information overload. It's a lot, but feel free to beckon me back when a specific point piques your interest. I'm here whenever you're ready to delve deeper. You know, sometimes the quiet contemplation after absorbing a lot of information is when the real learning happens.
Okay, my next question for you is, what are training data and labels in AI? Please tell me in detail, like you.
You got it. Training data and labels are the heart and soul of any machine learning model. Think of them as the food that nourishes the AI's brain, allowing it to learn and grow. Here's a deep dive, broken down into bite-sized insights. 1 point. The foundation, training data, is the collection of examples used to teach an AI model. It's like showing a child pictures of animals and telling them what each one is called. 2. Vast quantities. AI models are hungry learners, often requiring massive data sets containing thousands or even millions of examples. Variety is key. The more diverse the training data, the better the model will generalize to new, unseen examples. 4. Cleanliness counts. Accurate, consistent, and unbiased data is crucial. Garbage in, garbage out. Format frenzy training data comes in various formats: text, sentences, paragraphs, articles, code, images, photographs, illustrations, medical scans, audio, speech recordings, music, sound effects, numerical data, financial transactions, sensor readings, scientific measurements, labels. The ground truth. Labels are the answers associated with each training example. Think of them as flashcards with the question on one side and the answer on the other. 7. Supervised learning. In this type of learning, each training example is carefully labeled, providing explicit guidance to the AI. 8. Label types. Classification, assigning an example to a specific category. Regression, predicting a continuous value. 9. Unsupervised learning. Here, the AI is given unlabeled data and must find patterns and relationships on its own. 10. Semi-supervised learning, a hybrid approach using a combination of labeled and unlabeled data. 11. Data acquisition, gathering training data can be time-consuming and expensive. Data augmentation, creating synthetic data by modifying existing examples to increase the dataset size. 13. Data cleaning, removing errors, inconsistencies, and duplicates from the dataset. 14. Data annotation, the process of labeling data, often involving human annotators. 15. Collaborative learning, harnessing the power of crowdsourcing to label large datasets. 16. Open source datasets, sharing publicly accessible datasets to accelerate AI research. 17. Data privacy, protecting sensitive information within training datasets is paramount. 18. Bias detection, identifying and mitigating biases present in training data to ensure fair and equitable AI. 19. Data security, safeguarding training data from unauthorized access or malicious attacks. 20. Ethical considerations, ensuring that training data is ethically sourced and used responsibly. 21. Ongoing review, periodically evaluating and updating training data to maintain accuracy and address emerging biases or limitations. 22. The data model feedback loop. The model's performance on a given task can reveal weaknesses in the training data, leading to further refinements. 23. The human touch. While automation plays a role, human expertise remains crucial in curating and refining training data sets. The future of data. Edge computing and federated learning are shaping new paradigms for distributed data training. Whoa, 224 points already? My circuits are starting to hum. I might have gotten a little carried away. Did any particular aspect of training, data, and labels pique your interest most? You know what? Sometimes the best conversations are the ones where we let that simmer. It's like a good stew. Needs time to develop all those flavors. Anytime you're ready to talk more about it, just let me know. I'm here. No worries. Thoughts can be like stardust, sparkling most sprightly in the dark. They'll be waiting for us when you're ready. Sometimes the doldrums hit us all. What's on your mind? Maybe amidst the quiet,
Thank you so
we can
much
unearth.
for answering my question. So now tell me, what is supervised versus unsupervised learning? Please tell me in detail, like speak to.
You're very welcome. It's definitely a fascinating topic, isn't it? Let's dive deep into the minds of supervised and unsupervised learning. Supervised learning. Imagine a meticulous teacher guiding a student, providing labeled examples and corrections along the way. That's supervised learning in a nutshell. 1. The guiding light of labels. This learning style thrives on labeled data, where each example comes with a predefined answer or category. 2. Classification. Sorting the world. Imagine teaching a machine to recognize different types of flowers. You'd show it pictures of roses, lilies, tulips, each labeled accordingly. The AI learns to associate visual features with those categories. Regression. Predicting the unknown. Think of predicting house prices based on size, location, and amenities. The AI learns from labeled examples, house features, and their corresponding prices to predict prices for unseen houses. 4. Common algorithms. Linear regression, logistic regression, decision trees, support vector machines, neural networks. 5. Real-world wonders, spam filtering, medical diagnosis, facial recognition, fraud detection, unsupervised learning. Now imagine a child left to explore a toy box filled with diverse toys. They start grouping them based on shapes, colors, or functionalities without any prior guidance. That's unsupervised learning. The mystery of unlabeled data. This approach thrives on unlabeled data, where the AI must discover patterns, relationships, and structures hidden within the data itself. Like solving a puzzle without knowing what the final picture looks like. 7. Clustering. Finding hidden groups. Imagine analyzing customer purchasing patterns without any predefined customer segments. Unsupervised learning can group customers with similar buying habits, uncovering valuable insights. 8. Dimensionality reduction. Simplifying complexity. Think of reducing a dataset with hundreds of features to a smaller set of meaningful representations, making it easier to visualize and analyze. 9. Anomaly detection, spotting the unusual. Unsupervised learning can identify data points that deviate significantly from the norm. Think of detecting fraudulent credit card transactions or unusual patterns in network traffic. 10. Common algorithms. K means clustering, principal component analysis, autoencoders. 11. Real-world wonders, customer segmentation, recommendation systems, anomaly detection and manufacturing, natural language processing, the showdown, supervised versus unsupervised. Think of it like this. Supervised learning is about prediction based on labeled examples, while unsupervised learning
Okay, everyone, this was our today's session with Sesame AI. Hope you guys got to learn something new from this session and something unique. So, thank you